COVID-19 has been a menace for over a year, and although we are on the road to recovery, there's still a long way to go. A major obstacle to recovery is the lack of information. It's hard to stay safe when you don't even know which locations have a high density of people or which places have had infected visitors.
To fill this lack of information, we created HotSpot, a location based contact tracing iOS application which alerts users in real time to locations with confirmed cases so that they can make a conscious choice to avoid them. Additionally, we forecasted the safest times to visit a store. Finally, we developed and trained multiple machine learning models to predict the number of COVID-19 cases. There are two ways to sign into Hotspot. First, users can use a pre-existing Google account to sign in. We can use the Google identification platform to confirm Google accounts with this method. If you don't have a Google account, the second option is to create an account using Google authentication. You can set a username and password and specify if you have COVID-19 related symptoms. With this approach, we use Google OAuth, an internet protocol allowing third parties to exchange data without the user actually having to sign into an account. As such, the user's privacy is maintained as their password is hashed using a bcrypt password hashing algorithm. Google Sign-In can also authenticate the user for us and internally query the user's email into Google Firestore.
After a user logs in, Hotspot uses the Radar.io software development kit to perform location search in the background to determine if a user enters a retail store. Once again, we protect user privacy by only searching for nearby stores once the user has moved a certain distance and is away from home. Once Hotspot has determined that the user is visiting a store, the information is stored on our secure Cloud Firestore database. At any time, a user may report that they've experienced COVID-19 symptoms or have tested positive. In this case, Hotspot displays locations for the user to confirm that they have visited in the previous 2 weeks based on data stored in Cloud Firestore. After the user has confirmed travel to these locations, the confirmation is pushed to the Cloud Firebase. Now, other users can see a red danger zone on the map feature, which will alert them of COVID-19 cases. Locations that have a large number of visitors will show up as a yellow warning zone in the map feature. The map is refreshed with the latest Firestore data every time it is opened. After 2 weeks of being reported, the hotspots will automatically disappear. Even if we have just a few helpful neighbors who report cases in certain locations, we can help hundreds of people avoid these danger zones when they look at the map. If a user accidentally approaches within range of a danger or warning zone, the geofencing feature will activate, and they will be alerted by the app to take a different route. A push notification is automatically sent by Hotspot so that there is no need to constantly check the map.
Another main feature of Hotspot is a forecast dashboard. Users can select locations from the map that they wish to visit later. Hotspot will then generate a prediction for the safest times to visit this location on a given day, as well as various statistics regarding visitor traffic, such as the mean hourly visitor count, peak start, and max time. A graph also displays the busyness today with the number of hourly visitors predicted. The user may then choose to receive a notification. Based on the guidance provided by the Busyness Today chart, users can select a time at which they can wish to visit a certain location, considering their schedules. Hotspot then generates a calendar event and reminder for the user on their personal iCal. The calendar event is customized with the event name, and personalized notes are generated by Hotspot. At the bottom, the user has directions to visit the store using Apple Maps. As such, there's no need to take the risk of getting groceries at a potentially crowded time when Hotspot can inform you of the time with the least foot traffic. We also decided to create a choropleth heat map distribution chart of COVID-19 cases for each county in the United States. A Python script parses through the raw New York Times COVID-19 cases data per county based on the FIPS postal code and creates a visual heat map.
To predict the number of COVID cases in a location on a given day, we trained 2 machine learning models using PyTorch on the Johns Hopkins COVID-19 dataset. The first model uses support vector regression with an input of a day number since first case and output of number of cases on the specified day. We used a radial basis function kernel and a regularization penalty of 10 to the 4 to train the SVR, and we were able to predict the number of cases for a specific county with a correlation coefficient of over 0.99. The drawback to this approach is that this model has to be trained on certain counties at a time. We tried to make the model more general by using an artificial neural net with longitude and latitude as input features as well. The model architecture was 4 hidden layers with 4 nodes per layer, Xavier initialization, and ReLU activation. We achieved a correlation coefficient of 0.66. However, as you can see, our SVR model very closely modeled the infection trend.
In summary, we hope that HotSpot can play a role in preventing COVID-19 spread. We would like to thank Google Cloud and our mentor, Haniel Diaz, for providing us with the opportunity to continue expanding on HotSpot.